Testing, testing. Hello?
Testing, testing, 1, 2, 3, testing, testing.
Rob, you get a handheld. Or you want this? Camera guys, you ready? Guess not. Ready? You okay? Okay. Hi, everybody. Hi. I'm really excited to be here. I'm from Montreal. Well, I'm actually from California, but I came from Montreal. It's a long flight, kind of jet lagged. So if I'm a little spacey, I apologize. I'm going to tell you a little story about building the bionic eye in 2 weeks. My name is, I don't know what my name is. Go. My name is Costa Grammatis. I live on couches. I travel the world, find very interesting and unique engineering projects, and try to make them happen. I heard about Rob in Wired magazine. Rob is the guy with the eye patch right there. You'll hear about him a little bit later. I read about him in Wired magazine. He was trying to find some engineers to build a prosthetic eye that could shoot video. He's a filmmaker, and he had a vision for a type of cinematography where for documentaries, where you go around and you shoot people from the actual perspective of his eye. He lost his eye when he was a kid. How old are you? 9 years old, in a shooting accident. And how do you turn a bad situation to a good situation? I don't know. You build yourself a bionic eye. So I read about it in Wired magazine. I'm like, all right, I'll try. I sent him an email, and lo and behold, he came out to San Francisco, where I was living in a warehouse. And we totally got along. And he's like, come on down to Toronto and live on my couch. And I said, sweet. So our mission was to cram a video camera, a wireless transmitter, and a battery all inside Rob's empty eye socket. Sorry if that creeps anyone out. I'm very used to it. For close to $0, because we have no funding of any kind, and we had to do it in 2 weeks. 2 weeks is the really important part, because Rob wanted to go. He was invited to this Future of Journalism conference in Brussels, and if he had an eye to debut at the conference, it would be huge, because Reuters was there, the AP was there, everyone who's big in the news industry was going to be there, and they'd cover this story, and hopefully that would launch his kind of Iborg career, if we were able to accomplish it. So I'm going to tell you a little bit about the different ways we went about solving the problems in a 2-week time frame. Mechanically, the eye itself is about 30 millimeters across and 2.75 millimeters tall, 12 millimeters thick, and inside the tallest space is only 9 millimeters. So it's a really cramped space to work in. I'm sure you've seen like the little spy cameras that you bought when you were in high school and tried to like spy on people. Those don't work in this situation because they're just too thick usually. We only have 9 millimeters. So our job was to kind of take one of those cameras and spread it out in a thinner way. So we got a laser scan of Rob's eye that we never actually got to use until way later, but we found an ocularist who was able to take an impression of Rob's eye and cut it in 2 halves and make a mold, and you take those 2 halves and you put them together and there's just an empty space inside. It's nothing like breathtaking. You seal it with wax and you have a prosthetic eye that's hollow inside. We wanted to do it with rapid prototyping, but upon doing some research on like, so will this material kill Rob? All the rapid prototypers were like, I wouldn't put it in his head. So we were kind of like, couldn't do anything about it. I guess they use toxic chemicals in that process. The camera itself was given to us by our lovely sponsors at OmniVision. Rob worked really hard to try and get a camera company on board that makes really tiny cameras. And OmniVision currently, this is the smallest camera that we know of. I don't know what the NSA is doing, but this is a really small camera. 3.2 millimeters square. It's used in endoscope work, colonoscopies. You can imagine why they need such a small camera for that kind of places. It has 328 by 250 pixels of resolution and just a regular NTSC output. It's quite simple to interface with. All you need is a clock signal, some power, and a resistor. I would be scared when I got this camera, when they sent it to me for the first time. I'd read about it, I'd seen pictures of it, but it is so small you can like sneeze it away. And I would never undress in public again. Like, not that I undress in public in the first place, but in any place that could be kind of public. Powering the camera was, that is the hardest challenge that we had to face, because a battery has a limited power supply. In that size, there's not that much power that can be fed into the cameras and the transmitters. We wanted to use, we thought a whole bunch of different ideas, like kinetic power. Rob would be like this all the time, powering his eye. Hydrogen fuel cell. The University of Illinois just came out with this really tiny hydrogen fuel cell. I was reading about it, but it can only supply like 0.1 volt at very low current, so that was useless. Solar panels, like in the front, how cool would that be if you had like little solar panels in the front? And then I was like, well, what if we, and then I started thinking like really hard outside of the box, like what if we nuclear powered his eye? And I thought that's a wild idea, that's crazy, that would never happen, but apparently they do this. Back in the 70s, when nuclear was all cool, I guess, they made pacemakers that ran off nuclear batteries. It had like thermopiles and then little plutonium nugget inside of it. And they're really small, but not small enough to put in Rob's eye. So, induction was another idea. We were like, how could we beam high-power radio waves into Rob's head? He was a little concerned. I was less concerned. But it was the technical challenge of using induction. He'd have to wear like eyeglasses or a hat to be in the same plane of his eye, or like how it sticks something on the side of his head. It was cumbersome, and it wasn't going to work in 2 weeks. So we went with a battery. We found like this company called PowerStream that makes the smallest lithium polymer batteries I've ever seen. 5 by 9 by 10 millimeters. They were specifically designed for these RC helicopters. I don't really know what the story is, but I think there was a challenge to make the world's lightest RC helicopter, so like they went crazy with it. We wanted to use coin cell batteries, for like hearing aids or your watch, but they can't supply enough current, and we're always concerned about things blowing up inside of Rob's eye. If any of you've seen a lithium polymer battery fire, which there's more on that later, you can testify. So that was our battery. We wanted one of the requirements was that it had to transmit video out. We were thinking about onboard storage, but in 2 weeks, that would be a bit of a challenge to implement an FPGA or a microcontroller. The output of the camera is 2.9 megabits per second. Zigbee didn't have enough bandwidth unless we implemented some compression algorithms, but it did have it didn't suck that much power. It was very power friendly, which is good. Bluetooth and Wi-Fi had complex stacks that needed to be implemented on a microcontroller, and also they had a lot of power requirements as well that we couldn't really speak to. If you remember, the battery only had 15 milliamp hours, so we don't have a lot of power to play with. We have an RF team that we found some people who are well-versed in RF, and we decided to just use an analog transmitter. We found so small, a 6 millimeter square RF transmitter. It operates at 2.3 gigahertz with a regular NTSC output. Can't really get the scale of it, but it's just really small. The camera PCB itself, we needed something really thin. Like I said, one of our problems was the thickness of the eye. We have a lot of space around, but not a lot of space in depth. So we talked to a lot of different PCB manufacturers, and they all said, we can't make it that thin. We can't make it. They wanted to make, like a regular PCB board, 1/8 of an inch or something. And I'm like, that won't work. But we found this great company, and they took, if you've seen like layered PCBs, they just made one layer of a PCB, and that's 0.01 inches thick. It's like a sheet of paper. You can bend it. You can bend this PCB. We use BGA packages for everything, so it's very tightly packed. I tried, when we got the boards made, I was really excited, like, I'm going to bring them home and make it, and I tried to reflow it on Rob's oven, because we don't have any tools. I don't even have a soldering iron. That didn't go too well. It just kind of, because they bow, because it's just it's as thin as a sheet of paper. It doesn't lie flat. So when it gets hot, it bows, and then the BGAs move around. And so we found another company who does assembly, and they put the boards together. The whole place was just people in front of desks soldering all day. It's amazing. I could never do that job. Much respect. So you can see 12 millimeters square or round. It's a pretty small board. Optically, so you have a sensor and you need a lens in order to see anything other than just like light and dark. I don't know anything about lenses. It's a completely magical, mythical world of playing with light. And I just tried reading about it, but when it really comes down to the nuts and bolts of building a lens or buying a lens, there's nothing really available off the shelf. So we called Omnivision, our sensor supplier, and we're like, hey, you guys have any lenses? Like, who do you use for lenses? And they're like, oh, we don't really know, or they wouldn't tell us. And we eventually got them to root through their desks, literally, and find lenses that they'd used in prototyping, and they sent those to us. We do have a guy right now who's working on sort of a custom lens just for this. The lenses that Omnivision gave us have a really shallow focal point, so it's for endoscope, so it's for looking at things really close. So basically everything Rob sees pretty out of focus at a distance. Another thing I had to worry about is you have a lens inside the eye, and then the front of the eye, unless it's flat, becomes a lens itself. So we were really worried for a while that it was going to just be a big blurry blob. But we figured out that if you move the lens, if you move the camera around appropriately, you can get it into a really good space to see through it. But it's kind of a guess and check. There's no real science to it. Instead of having controller inside the eye itself, we built an external control board that did gain control and saturation. It controls the camera. So we set it up. We have the eye. It's running. We have the control board connected to it. The control board programs the camera, and then we remove the control board, stuff it inside the eye socket, and stuff it in Rob's head. It's really easy, straightforward. We couldn't fit all the PIC, the microcontroller, inside the space of the eye in the time. So it's a pretty straightforward endeavor of connecting everything together and hoping that it works, right? We've been working for 2 weeks. Rob is freaking out because he's about to fly off to Brussels. I'm freaking out because I've never tested this thing, I've never put it together. And Rob has the brilliant idea of okay, for the first go, we're going to put you in a film studio with a red camera and lighting all around you so we can watch you assemble it. And I'm like, Rob, this is engineering. It never really works the first time. I've never seen anything work the first time. It's so rare. He's like, don't worry about it. It'll work great. Just hook it up. Come on, Costa, just hook it up. He had all this faith in me. I'm like, you sure? So, of course, the inevitable happens, and I let out the smoke. I don't know if you're familiar with this term. I learned about it at my old employer, SpaceX. I built a lithium polymer. I was working on a team to build lithium polymer batteries, and this thing caught on fire inside of its enclosure. It burned for 8 hours. It was incredible. But my enclosure held it in, so it was a pretty amazing feat. So Rob went off to Brussels. He didn't have an eye with him because I didn't have the time to figure out what was wrong, nor did I have the tools. But he talked about the project anyway, and he ended up talking to people at the AP and Reuters, and I was totally blown away when the next morning after the conference, my phone is ringing off the hook. Hey, we heard about this iWork project, what's going on? Rob doesn't have a phone because his phone doesn't work in Europe, so they're just calling me. And all the reporters want to talk, and then Fox News calls, and they're like, we're going to send a car over, we're going to pick you up, and we're going to talk about the project. How does it sound? And I had an hour to get ready. So I go on Fox News, and I basically have to explain, yeah, it caught on fire. That's all I really have to say, because it's not done yet. But we have this new charge. We're all empowered. The press is interested. People are interested in this project. Can I borrow somebody's oscilloscope, please? I really want to know what's wrong. I literally put an ad on Craigslist to find an oscilloscope to use. I was calling universities because I had no idea what was going on inside of this eye. I knew that I had blown a voltage regulator. That was one of the problems, but there were other problems as well. And how do I solve anything without multimeter or a good soldering iron? I don't know. Finally, it did work. And I have a little movie of kind of this journey, and in the end, you'll see some really bad footage of it working. I want to show that to you right now. Audio? Oh, hold on. Wait for it. False start. Hold on. Technical difficulties.
There's a filmmaker planning to implant a tiny camera in his artificial eye. Spence says he got the idea to fight crime after he lost his eye in an accident as a teenager.
Built it in his living room, in Rob's living room.
You spent 3 weeks in Rob's living room.
We are here to see if the bionic eye that Kosa designed will work. There's room inside for the components.
Oh, smoke's coming off it.
Really, your regulator just blew up. Why? We fired it all up, and then it kind of caught on fire.
Man, I hope that does not happen inside of this guy's eye.
Sorry, though, have you guys heard about the story about the Canadian filmmaker? His name is Rob Spence, and he replaced his false eye with a camera. Have you read this? It's real. It seems like a really controversial thing to do.
You'll see blinking, glancing around, perhaps sometimes not where I'm supposed to be.
Are you single, I have to ask?
And a lot of female reporters ask me that, actually. So.
Holy Krakatoa! That is amazing.
Eyeborn.
I have become eyeborn.
This is the LED eye window.
I am eyeborn.
How else do you test your batteries?
Hey, eyeborn loves Johnny Rockets.
Thank you. Okay. Now where was I? Okay. What's coming down the road? Because now we have more time than 2 weeks, so we're thinking a little bit harder. We'd like to build an eye with onboard storage, an FPGA, memory, all crammed inside of this eye, because we're realizing that wireless transmission, whether it be digital or analog, you can only go like 2 feet. If you saw in the video, we had the receiver, unless we use like a directional antenna or something, had to be really close to his head. It's not very powerful, and I'm not really an expert in anything RF. So we're trying to make one with onboard storage, and we're also working in the same route of wireless, but we're trying to learn more about how to do that effectively. We want to build a housing that can snap together instead of using wax, because it's really disgusting. After you like take it out of Rob's head, you got this like globs of Rob's eye snot and like wax. I have to like wash this off. And then hopefully we'll get some funding so we can stop doing this on the zero budget that we're doing right now. That picture right there is a camera that we've been working on. It's really, really small. A lot of people have asked, and also if you want to get involved, by all means, contact me, contact Rob. We'd love to building teams. A lot of people have asked about restoring vision. We get a lot of emails from people who have suffered some sort of tragedy and lost their sight, and they think that the iBoard project is about restoring vision. And we're not directly restoring vision, but we like to talk about it because there are some great projects going on that are all about taking electronics, fitting them in the eye, and solving the problem of why can't you see, solving blindness. I got to go to the University of Montreal and talk to a wonderful professor there named Mohammed, who is working to make these little implantable chips that snap right on, get plugged into your optical cortex and stimulate that area of the brain. The way he's testing it right now is like he has mice, and he teaches them to find food based on like really bright lights. So he shines like a really bright light in one eye, and that's where the food is. And he was able to, after cutting their optic nerves to have them find food based on stimulating a certain part of their optical cortex. So that's sort of like the state of the art in going straight into the brain and helping people see. And then there's other projects, retinal implant projects like the group called Retina Implant and the Boston Retinal Project. And what they do is they literally stick a piece of silicone in the back of the eye, and it stimulates either the nerve or the retina. Currently, there's about, I think it's 13 pixels of display, something around that, that people can see. That it's already been tried on a person. And he was able to see after not being able to see for years. But it's not actual vision. It's a light, bright view of the world. It's fascinating work, and I hope to kind of become involved with that a little bit more as we move in this direction. It's all kind of on the same world, same problems. Anyway, I want to thank you guys very much. You can visit the iBoard project. Rob's going to talk right now a little bit more about sort of the philosophy behind it. And thank you so much for having me here.
Oh, you need a special adapter for that? Yep. Does somebody have a Mac adapter? Come on, there's like a million hackers in here. Somebody has to have a... Please. When I saw so many other people with their Macs, I thought that... Here we go. I think it's... right here. Yeah. Okay. So yeah, it's a strange thing that I did with Costa's help, and Costa was a huge help. Thanks, Costa, again for your work on that. And thank you to HAR 2009 for inviting us here. It's really a cool phenomenon. I was walking around last night, see like 20 guys in a tent with beers and weird music and all working on God knows what, but I'm intrigued, and I'm like, what are they working on? You know, I like it, and I think that Costa and I feel appreciated here. We feel like we're amongst people that sort of get this whole thing that we're doing. You know, a lot of people have asked me, did you just pull this idea out of your ass? And I'm like, well, we are using a colonoscopy camera, so we could just check if we want to. Costa hates that joke. I've told it a million times. Are we up on the air yet? I got to do something? Costa. Now, let's see. What would it be in my display? F5. stand by. I'll try voice. Computer. Compensate. Shields. Let's see. Detect displays. It's a Mac. I'm not sure.
Anything about Macs either.
Just
Option.
yeah.
It's one of these keys here.
Mac is Linux based.
Did I do it? I don't know.
Usually it just goes straight to.
Option, command. Didn't do anything. Guys, I don't know.
Can you do it without the sound?
Sorry. I really don't know.
Hey hackers, any Mac heads out there? Take it out, plug it in again. I love that. That's what I usually do. It's doing the stuff it normally does when it goes to. Yeah, no, I've tried detect displays. Yeah, I'm not sure why it's not. Gather windows. No. Nope.
In that case, it doesn't see a second display, it only sees one.
Guys, I have like a video out. Can you work this video out? Like I have to, yeah, like that.
Well, it should be possible.
Okay.
All right, maybe I'll just go freestyle. It's too bad. You won't be able to look at pictures. Turn it. I'll try one more time just to turn it on and off here and see if that helps. Oh, I see, yeah. So just while I'm trying to get this going again, one of the things I found with this project was I've actually been working on it for quite a while, and I developed some relationships all over the place before I met Costa. But one of the things I found with a project like this is that, oddly enough, it's the young people with not that much experience that can really push a project forward. Originally, I was working with older fellas that were, the top of their field, multi-award winning types. And I found with them, they were often like, well, here's what you're doing wrong, Rob, and you can meet me next month for lunch, and we can discuss it again. And, that's fine. There's a $6 million man. I'm the $0 million man, so there's no budget there. But there's something about young people like Kosa that's almost like they're too stupid to know that it's impossible. And I say that in the kindest way, because it's just like, well, let's just try it, let's just go for it. And even the Kosa, and there was another fellow who actually made the two-part prosthetic eye that's hollow in the middle by hand, and he had the same attitude. I'd been working with another guy for maybe, 7 months, and it was just, no, well, it's impossible, and, And then this guy just basically did it, along with Costa's cajoling, in, a couple of weeks. So it was just a real reaffirmation for me, that stuff, it's so easy for people to say stuff is impossible, you can't do it, but, part of you, I think, just has to be kind of like, no, it's not. Let's see if there's any action there. Yeah. All right, well, I guess I'll just freestyle it here. A different Mac? You know what? It's going to take too long to pull it over, and I'll just see if I can. We can what? Oh, we could, I suppose. Yeah, if you guys want to do that. That's. I cannot dance. Later tonight. Okay. So get my PowerPoint open here. So the first thing that, where this project started, obviously, was I lost my eye. I was trying to shoot a pile of cow shit when I was 9, which I successfully hit, but I wasn't holding the gun properly. Then the eye deteriorated over the years, and eventually I had it out, I guess, about 4 years ago. Now, I'm a filmmaker, so I was like, well, this is great. I've got a hole in my head. I'll just stick a camera in there. It'll be awesome. So I began the process of calling around to companies. I would try to find keywords from people that I met or talked to on the phone. Fortunately, nerds are very enthusiastic about a guy sticking a camera in his head, and even though I don't have a budget, I have sort of unbridled, enthusiastic, sort of almost squealingly behind me types, all men so far. There could be a woman on the iBorg team at some point, but not yet. And so it's been a really positive experience. I think maybe 35 different engineers have weighed in and sent back and forth emails, and some have done more and some have done less. It's kind of an open source project, not unlike the previous speaker to me, whose their project is making prosthetic limbs much cheaper for people in Indonesia. Obviously, I was inspired by the Bionic Man, as you saw in the video, and so it's not that original idea, really. I mean, it's just something that's out there, and I don't know if you remember the Bionic Man toy. You could actually look through his little eye. So this is something I had in mind. The way that what they do now when they remove an eye is they pull it out, they cut it out, but then they put in a ball of sea coral. Sea coral, like, that porous stuff under the sea that the Swiss fish swim through. And it's very organic. And what happens is they put in a perfect ball of sea coral, and the muscles and the blood vessels grow into that porous material, so that what happens is you get stereo movement, because the muscles still move in stereo with the remaining healthy eye. And so what this means is that you can drill a motility coupling peg, which you saw in the video. It's sort of alarming. But they drill in a peg, and then they make it indentation on the back of the eye. So it's sort of, like those shirts, So then you get the movement, which is not what it, like your uncle that used to scare the kids at the wedding. He'd just have a sphere. This is actually a bit shaped around the ball of sea coral. So, what's interesting is a lot of people have been calling me a cyborg, including myself. I call myself iBorg.
cyborg and I together. And it's interesting what people consider a cyborg, but what I've discovered is that, for example, somebody with a prosthetic eye is not considered, in popular terms or by most people to be a cyborg. That's just like a man with a prosthetic eye or a person with a prosthetic eye. However, you put a $5 red LED light into the eye, and oh my God, this guy's a cyborg. Holy, And so, why is that? How do we define cyborg? By some definitions, clothing makes you a cyborg because it's essentially technology that augments, a naked human animal. But I think that what we've, especially people who are on the blogosphere and people like yourselves, people who are sort of more interested in cyborgs, there has to be an element of pop culture, almost, so that looking like the Terminator, or wearing a red tracksuit like the Bionic Man, it's tapping into this this fascination we have with those characters we know from Star Trek, from Terminator, and so on and so forth. But certainly, as we go on, we don't consider clothes that highly technological, but our great whatever grandchildren may consider a nanobot built eye to be as casual as clothing for us. Indeed, some people say, well, we would never cut into our body, but I mean, let's go to Hollywood for a second here and look at a lot of women's breasts there, and even people who are doing a lot of piercings, this sort of thing. I think the people are just willing to cut into their body very easily these days. One of the guys that was helping me with this project is a guy called Steve Mann. I don't know, has anybody heard of Steve Mann? Yeah, he's a guy, he was involved in starting the wearable computing department at MIT, and he's at U of T now. He had some interesting ideas. He wears a camera on his head and has done so since the 80s when he had like a giant backpack and antennas. And so he was a guy that obviously was a go-to guy for me to talk about all this stuff. And one of the areas, besides building this camera that continuously records his life, one of the areas he's looked at is surveillance. Because, wearing a camera on your head all the time, this raises some questions. It provokes questions about, Orwell and this kind of thing. So one of the terms he came up with was surveillance. So there's people with oversight, let's say the government or corporations, that are looking down and recording data of us all the time. But in a way, him wearing a camera was an antidote or a balancing of power with surveillance, which is the French word for watching. And so he said if enough people with their cell phones, with their own cameras, provided a separate point of view from, let's say, the little brothers of the world as opposed to the big brothers, then you'd have what would be called equivalence. This is fraught with ethical problems, such as me going on a date, with a woman with a camera. I often get asked about this, like on the video. I don't actually plan on life casting. I'll just put the camera in when I want to use it and take it out. But I am interested in recording people without them knowing it. The difference for me would be, because I'm a documentary filmmaker, I would ask for a release form. So if I interview you and you don't realize I'm interviewing you, and the interview's done, and I say, okay, I just got a very natural conversation with you for once as a documentary maker, because if I put a camera in front of your face, you're not really acting like yourself, you're acting like you on camera. So I think this is a reasonable thing to get people to sign a release form after they've done the interview. If you're not comfortable with what you can recall of what you said, then you don't have to do it. As a filmmaker, I also think it's really interesting the film language that you'll get out of this moving, blinking eye, and I've had some success with working out how that aesthetic is going to be. First of all, the video quality is almost exactly the same as the point of view of Terminator in Terminator 1, which is a very lucky aesthetic serendipitous moment for us because it just, people buy into that kind of stuff. Second of all, I'm getting that direct pupil-to-pupil eye contact that within human interaction, I think it's a magical thing to look right. This is when, when we tell people we love them or when we sincerely meet them or have a very close conversation. This is where my lens is going to be, and the prosthetic eye looks quite good. I think, too, that we're so used to film language being a rectangular sort of perfect eye of God, moving slowly and then staying on the tripod. But this is starting to change with, let's say, the Blair Witch Project, or professional cameramen emulating less professional use of cameras. So not unlike acting that, let's say was, Philip, what's going on? I don't know, Martha. It wasn't really the way that we act. This kind of filming will be much more like the way that we actually see the world, glancing around and blinking and so forth. There has been some concern about the safety. Kosa was joking around. Usually journalists ask me, are you comfortable with those kind of rays and things so near your brain? And I'm like, well, are you asking me that question from a cell phone? Because I have a giant ball of sea coral that's actually protecting me more than the Nokia you're using that it's going into your brain. So I think we all have to be concerned about cell phones and eye cameras, but it's actually quite safe, except for the potential explosion of a polymer battery, which, fortunately, though, Kosa has good experience in making enclosures strong enough that that's not going to be a problem. So, finally, I've got a lot of criticism, and blogs and stuff. I've got a lot of press, and people kind of feel like I'm this potential creep, like for some reason, me with a camera in my eyes is worse than, say, everybody else who's got a small video camera. Like for some reason, I'm going to abuse this power more than everyone else. I guess it's more easy for me to do so. But I think the way things are going, that there's just going to be more and more and more video data around from everybody. And it's very possible once we're post-humans that why wouldn't you record your data or have a continuous record? So issues of privacy and ethics are all starting to change. One of the things I found most interesting, though, about this debate is that of course, we're worried about government surveillance cameras and what Google's Side Earth is doing. Like, are they getting a picture of me kissing my mistress, while they're going by? What about, and thank God you guys are around to figure out what software companies are like, how much of our data are they grabbing and where is it going? I think there's big brothers that it used to be easy. Big brother in the state, that's the problem. Now there's little brothers, guys like me with eye cameras or cell phones you have to worry about as well. And there's corporations, like are they big brothers or little brothers? But I think that, to speak to you guys directly, what makes me feel more comfortable about the whole thing is, and I don't think it's an us versus them thing, I think it's all of us anyways, is that there's these sort of the modern civil rights activists for all this technology stuff that people don't understand are you guys. Who are doing strange things in tents, and probably doing us all some good, like trying to figure out what the hell is going on with all this technology that's moving so quickly that we don't know what to do about it except for maybe stick cameras in our faces. And so that wraps it up. I guess, does anyone have any questions for Kosa or I? Does anyone have any smart-ass remarks for Kosa or I?
Hello.
Yeah,
First of all, thank you very much.
Hello.
Have you thought about using a camera that records a different wavelength, like infrared? So you could have night vision or something?
Yeah, well, the great thing about having a bionic eye is that unlike you puny humans, we can just keep changing and upgrading and 3.0ing and whatever else. So we want to make an underwater camera. Costa assures me that there's some kind of benign laser eye that we can build, and I'm just kind of like, won't that burn the back of my eye? He says no. I don't know if anyone has a... But yeah, well, underwater cameras, infrared cameras, the sky's the limit, really. We want to, thermal, maybe a humiliation meter that might come in the future.
Hello. I just wanted to know if you'd had any contact with Kevin Warwick from the University of Reading.
Oh, over there?
He's the chap. He's the professor that's got the electronic implants in his arm.
No, what? I didn't. Repeat the question.
There's a chap called Professor Kevin Warwick of the University of Reading that is also a human cyborg. He has implants in his arm which he controls and hopefully relates messages to people.
Yeah, I spoke with Kevin Warwick because, ultimately I like to do a documentary about this in some form or another. And he's an interesting guy. He has a rat brain that's hooked up to a robot. So it's almost like the reverse of me. It's a robot with some mammal flesh as opposed to me, a mammal with some robot material. So Gordon is the name of this robot, and it's controlled by a rat brain. I really want to meet Gordon, and I think we might have a lot in common.
You mentioned that you wanted to make a documentary about this process, but it sounds like you sort of underwent this process in order to make documentaries. So can you talk a little bit about the kind of documentaries you might want to make that aren't autobiographical now that you have your cyber eye?
Sure. Well, I mean, part of the reality is that the broadcast market is shot to hell right now. Simultaneously, a lot of people are on the internet instead of TV, and the ad dollars have dried up. So I'm quite flexible within reason. Like there used to be a lot of places in Canada where you could do more of an auteur documentary, but they've almost universally gone. So the way I'm going now is more of a discovery route, so to speak. So I mean, they have their aesthetic that you can only bend so far. I mean, we've all seen Discovery, so it'd be like, Rob built his eye, like it'd be more of a straightforward thing than possibly some of the style of the editing you saw where I'm kind of like a jackass, that kind of stuff might not go over so well.
Any more questions?
You talked about different eyes that could see in like an underwater camera and other modifications. What do you think the limit is for you as technology continues to grow and change and there's other ways you can modify your body? How far do you want to go in becoming the $6 billion man?
Well, I definitely would not have removed my eye if I didn't have an accident. So, I think this kind of fell into my lap being a cyborg. It's not. I don't think but who knows? Maybe as I get older, I'll get more stuff in there. But as long as I'm safe, this is a fun thing to do, is to design a part of your body in different ways. And this is how a lot of people with prosthetics feel now. They're not trying to hide so much or just, they're looking to augment the function beyond regular human capabilities. So there's a guy like Oscar Pistorius from South Africa who's got these crazy running legs that are, I guess, 10,000 euros. His are probably a lot more. And other racers are saying, this is not fair. This guy with no legs is faster than me. Which, for people with prosthetics, we're like, whatever. Like, too bad for you. Maybe you should take your legs off.